Today's topic is scatterplots and correlations. Bivariate data is a representation that involves two variables. In most cases, we use the variable x to represent the independent variable and the y to represent the dependent variable. A scatterplot is a graph that has points plotted to show the relationship between two sets of data. So here we see three examples that are graphs and that have points plotted. So these are examples of scatter plots. Let's look at them closely. This first graph has a positive correlation because this trend is going up. Remember, we read a graph from left to right. So from left to right, this data is going up. We call it a trend because it's the group of points that are plotted. That's the trend. So the trend is going up. In this specific graph, the independent variable is the air temperature, the X values. Your X. And your dependent variable, which is your Y values, is represented by the speed of sound. So how can we describe this scatter plot and the variables? As X increases, so your X variable increases, what happens to your Y value? As I go up, your Y value is also increasing. So X increases, Y increases. So whenever it's a positive correlation, they are both increasing. Your both variables will increase. Now let's look at the correlation of this scatter plot. The correlation refers to the closeness of the points that are plotted. So these are pretty close because you could see almost like a line, right? It's almost a line. They're pretty close. So whenever the points that are plotted are close together, the scatter plot has a high correlation. And the correlation would determine if you could make any predictions, which we will talk about later. But correlation is very important. Are there any outliers in this scatter plot? An outlier is a point that is not following the trend. So let's look at our scatter plot. Are there any outliers? No, in this case there isn't because they're all closely together. They're all following this positive correlation. So in this case, we do not have any outliers. Let's look at the second scatter plot. The second scatter plot is an example of a negative correlation because as we read the graph from left to right, you could see that the points are decreasing. So the trend goes down. In this scatter plot, our independent variable, or your X variable, is hours of sleep. And your dependent variable is hours of video games. Now let's look at our variables. As x increases, so as we're going right on your x variable, what's happening to your y? So we go down, we go right, your y values are coming down. So as x increases, y decreases, and that's in a negative correlation. So let's look at the dots, at the points. Is this correlation high or low? So if we look at these, it's not as closely as this one, right? But this is still pretty close because we can clearly see it going down. So this correlation is high. Are there any outliers? Okay, so as of now, there aren't any, but let's add a point maybe here. Now, whenever you see a scatter plot like this and you see a point that's not following the group, not following the trend, then that is an outlier. So in this case, we're going to say yes, there's an outlier because we decided so, right? And it's just an example. An outlier will not be with the rest of the trend. Let's look at the third scatter plot. The third scatter plot has neither positive or negative correlation. It has no correlation because look at it. Can you follow a pattern? Is it going up? Is it going down? Can you tell? No, right? So it has no correlation because there's no trend. So if you don't see a pattern, it has no trend. And in this example, our independent or x variable is the length of call. And your dependent variable is your cost of the call. So let's look at our variables, x and y. Is one increasing or the other one decreasing? No, right? So there's no relationship. If there's no correlation, there will not be a relationship between x and y. And since we can't see the pattern, we can't see where the trend is going, this has a low correlation. And no outliers because there's not a specific place for looking. Everything's just scattered everywhere, right? So why scatter plots and why trend lines? This just helps us better see relationships between variables. And in the future, you will learn how to use scatter plots and trend lines to make predictions.